Welcome back to Riverina Institute. This practical session we're going to have a look at the magnetic effect created by an electric current. Here's our practical. We've got the power supply through a switch into an ammeter, through a coil, back to home, and we're measuring the voltage across. So with the voltmeter here, we'll use the power supply as our voltmeter, and I've got an ammeter already plugged in. So I'll just show you the circuit wired. Here we have our power supply coming out into the switch, from the switch into the positive of the ammeter, keeping in mind a digital meter will read positive and negative amps, but if it's an analog meter, make sure the positive's in the positive side so the needle goes the right way. Negative of the ammeter back into the coil, the other side of the coil back to the power supply. Before we start the demonstration using the power supply, I just thought I'd introduce a magnet. Here we've got an old traditional magnet. As we know, this magnet will create, or has a magnetic field around it, and that attracts metal. So if I put the magnet with the metal, I've got a said metal rod, I've got a bit of a line down the metal rod. If I put the magnet there, the metal rod rolls towards the magnet, like so. I think everyone's done that practical exercise at some point in their life. Magnet. And the same thing is going to happen when I turn on this power supply. I'm going to use two voltages. I'm going to basically start at 7.5 volts. Okay, the coil's got a certain amount of resistance, so it's going to have a certain amount of current flowing through it. Obviously from Ohm's law, I is equal to V over R. Voltage here divided by the resistance. The resistance of the coil is not going to change. So if I increase the voltage, I'm going to have more current flow. So we'll start at 7.5 volts. At 7.5 volts, this coil of wire is going to have a magnetic field created around it. Theory is the metal rod should be pulled into the coil on its own. Let me try that. I'll turn it on. 7.5 volts. Turn the switch on, around 1 amp flowing through this circuit. Same metal rod, I've got a little mark here, so I'll put it both at the same point. There, metal rod is attracted in, like so. One more. Now if I was to increase the voltage up to 15 volts, yes, obviously the current will increase as well. And here we've got the current up to around 2.1 amps because the coil is still a certain amount of resistance. The question is, will the metal rod go into the coil quicker? One would think that the more current flow, the greater the concentration of the magnetic lines of force around this coil, which means this should actually go into the coil quicker. Let me test that. So there. Just hold it again, same mark. One more for good luck. So I'll just turn that off because they do get a bit warm. So what we've seen there, that the current flow through a coil, okay, as per our circuit diagram, the greater the current flow, the greater the magnetic lines of force around the coil. These magnetic lines of force are building up around the coil. And the stronger that magnetic field, the quicker the rod goes in. That's the end of the session.